Okay, we're going to talk about some properties of logarithms. We're going to use a change of base formula. We're going to use some properties to evaluate and rewrite log expressions. We're going to expand or condense some log expressions. And we're hopefully going to solve and model some real world problems. Okay, so first of all, the change of base theorem. Change of base theorem, here it is. It says log base A of x is equal to the log base B of x over log base B of A, where base B is any base you want it to be. So log, I usually use common log, base 10, because that's the, standard button on a calculator. Yeah, and that's what this says. You can change to log base 10. You can change to log base E. Okay. So let's do an example. Log base 4 of 25, we could rewrite that as log base 10 of 25 over log base 10 of 4. So, you could do this with any base though. So you could rewrite this as, natural log of 25 over natural log of 4. So the change of base theorem, what it does, you take any log, any base of this argument, 25, over log any base, as long as it's the same as the numerator, of this exponent, or this base. Okay, so it's just that follow that pattern. That's the change of base theorem. Okay, let's see. Log base 4 of 25 equals x. If I change that to 4 to the x power equals 25 and take the log of both sides, this proves where it comes from. You can bring, one of the properties we're going to learn about is you can bring that exponent down, and you have log base 4 times x equals log of 25. Now divide both sides by the log of 4, and there you have the change of base theorem. So it's not hard to prove. You'll prove it in some of the homework problems. Okay. Let's try another one. Okay, so let's try part B now. Log base 2 of 12, you can just rewrite as any log. So it can be log base 5 of 12 over log base 5 of 2. Okay, log any base, as long as you stay consistent at the top and the bottom. All right. So some properties of logarithms are, these are three you're going to have to know. I just used one of them a second ago to prove this last one, to prove the change of base theorem. But basically the log base A of two numbers multiplied is the same thing as log base A of the first number plus log base A of the second number. It works with natural logs as well. As long as you actually works with anything, as long as you keep the same base. Log base A of two numbers divided is going to be the same thing as log base A of the numerator minus log base A of the denominator. It works with natural logs. And then log base A of some number raised to an exponent is the same as that exponent brought down and multiplied. So the exponent times log base A of the number. Okay, so those are the properties. Let's do a couple examples where we use them. Let's write each of these logarithms in terms of log of 2 and the log of 3. So I'm going to write this as the natural log of 2 times 3, because that's they want us to use natural log of 2 and 3. Now we learned that log, a second ago we learned a property that says the log of product is equal to the sum of the two individual parts. So we can rewrite log of 6 as log of 2 plus log of 3. Okay? And then we can do the same thing for this one. Log of natural log of 2 over 27, we can rewrite that as natural log of 2 minus natural log of 27. But they wanted us to use natural log of 3, so let me rewrite 27 as 3 cubed. And then I can turn this into natural log of 2 minus the natural log of 3 cubed. And I can actually bring this exponent down as well, so I'll make it natural log of 2 minus 3 natural log of 3. Okay, so I've rewritten this as an expression of logarithms with just log 2, log 3. All right. The properties are useful to rewrite and simplify. We're going to use these to solve equations eventually. Let's take a look at some more. This time let's expand, so let's go the other way around. We're going to expand each of these expressions. So we learned that the log of a product of things being multiplied, you can change that to addition. So you can change that to log base 4 of 5 plus log base 4 of x cubed plus log base 4 of y. It's a 4. And with this, I actually can bring down the 3, so I can put the 3 out front. And there's my expression that's expanded. Okay. Same thing here. Natural log of two things being divided. I'm going to change that into square root 3x minus 5 minus natural log of 7. So the log of two things being divided is the log of the numerator minus the log of the denominator. Now this is just an exponent, this radical. So I'm going to change that into 1/2 and bring down the 1/2. So it's going to become 1/2 natural log of 3x minus 5 minus natural log of 7. And that is as simplified as I can go. Or as expanded, I guess, as I could go. Okay? And we're not going to do this last application problem of basically we can take a data set and write a log equation from certain values if that relationship exists. But it's not something I'm going to quiz and test you over, so that's it for now, and I hope this video helps. We'll make a homework help video over the homework problems.